Hi guys, welcome back. This is the last segment of this lesson for week 7. So the last time we talked about pH and pOH, and remember that the total in the solution, the pH and pOH total in the solution must be equal to 14. Now let's move on and actually try to calculate what the pH is of a solution. So remember that there is going to be a tenfold increase with each step in the pH. This is not going to be a gradual step-by-step increase in strength. It's actually going to be an exponential increase in strength or even a decrease. A pH of 1, for example, is going to be 10 times stronger than a solution with a pH of 2. It's by tenfold, it means 10 times. Okay, so in other words, pH scale is logarithmic. And what logarithmic means is that it is related to exponential growth. And it is based on a power of 10. So we are going to use the log function and the inverse of the log, which is 10 to the x functions on the scientific calculator. And it really does depend on what it looks like on your calculator. And if you don't have a scientific calculator, you can always type in Google for scientific calculator, and I can show you that later. So the log function normally looks like this, log. And in relation to the log function, the backwards of that, the inverse, it's going to be 10 to the x. You're just going to have to look for it on the calculator. Usually, it's going to be close to where that log function is. In this type of calculator and in many calculators, the inverse of the logarithmic function is going to be at the top, and you're going to have to use the second button. But for my calculator, it just so happens that the inverse log is close to each other. The inverse log is separate. So you're just going to have to be familiar with your own calculator. All right, so to find the pH of a solution, we're going to use this equation. It's going to be equal to the negative log times the concentration. For pH, it's going to be the concentration of the hydrogen ions. And for the pOH, it's going to be the concentration of OH ions. Okay, so for this one, we're going to enter negative and then the log button. To find the opposite of that, to find the concentration itself, and if we're given the pH, we're going to have to use the inverse function. And the equation for that will be capital M. Capital M means molarity, and remember, molarity means concentration, equal to 10 to the negative pH, or to the negative pOH if we're talking about bases. And again, you're going to have to familiarize yourself with finding where that inverse log function is. Okay, so let's do these problems. I will do both problems, and you're just going to have to follow along, and I'm going to show you how to do this on the calculator using the Google Scientific Calculator. So let's go back to my document. Okay, so that would be number 18 here. And look, you just simply Google scientific calculator, and let me close that. You simply Google scientific calculator, and it should show something like this. And look, we've got the log function already. So for the first one, this first one here, the equation to find the pH is negative log times the concentration. This one is H, so it's going to be the concentration of the acid. That's what it's going to look like. So you enter the negative times the log, you press the log, multiplied by this concentration, 0.1. And let's put that in the calculator. So negative, press the log function, and this is what it's going to look like. That's correct. Make sure that it's negative. And the parentheses, and you're going to put the concentration value in there. 0.1. And the pH for that is going to be 1. The pH will be 1. That is your answer for number 18. Now for number 19, we're going to have to find a pH for 0.001 molarity of hydrochloric acid, HCl. Again, write the equation, pH negative log times the concentration of the acid, negative log times 0.001. Okay, and let's enter that into our scientific calculator. Let's clear that. Negative, press the log, and that one is 0.1, and your pH will be 3. It's going to be a pH of 3. That is your answer for number 19. Okay. Now, let's go to these problems. So we have a solution of hydrochloric acid, HCl. It's got a pH of 2.3. Find the following. You're going to have to find a pOH, find the concentration of the acid, and find the concentration of the base. Let's do this one together. So for the A portion of this, you're going to need to find pOH. So in the previous lesson, we talked about, let's do this part here for A. We talked about how both concentrations here, the pH and the pOH of a solution must be equal to 14. We're already given the pH of 2.3, so let's plug in the value of the 2.3 in this equation. 2.3 plus the pOH equals 14. pOH will be 14 minus 2.3, and your value for the pOH will be 14 minus 2.3. The pOH will be 11.7. 11.7, that is the answer for A. Now for B, this time we need to find the concentration of the acid. So do you guys remember what the equation is? If you don't, oops. This is the equation. Capital M for the concentration, molarity, equals the inverse of the log. So it's going to be, I take that back. It is going to be capital M equals 10 to the negative, and we're looking for the concentration of the acid here. So to the negative pH. And then you just plug that in. 10 to the negative pH, we are given pH here already, negative 2.3. Why don't we put 11.7? That's because 11.7 is for the pOH. That's going to be for C. So you got to make sure that you put in 2.3 because that is your given pH. Okay. Now let's just plug this into the calculator, and I'll show you how to do this on the Google calculator. So we don't see the 10 to the base power function here, but if you look closely, we've got the function for the inverse. Now watch what happens when I click this. Click inverse. Now we've got that inverse log function here. Click that again. The log used to be here. Find the inverse of this log, 10 to the base power. There you go. So what you're going to do, you're going to plug this in. You're going to press the function 10 to the x first. Oh, let me clear this off first. Okay. So press the inverse so that you get this function. To find the concentration of the acid, press the inverse log right there, 10 to the x, and this should come up. And that little, we've got a little blank there. And this is for the acid, so you're going to have to put in the pH value for the acid. And remember, you got to put in negative 2.3. And your answer will be this. That is your concentration. Let's see. So there are 2 sig figs here. We started with 2.3. That's 2 sig figs. So I want to use 2 sig figs. So we're going to stop right there after the 0 here, or just before the 1 here. We're going to stop right there for that one. So the answer for this is 0.005. That is your concentration. And now let's do C. This time we need to find the concentration of the hydroxide ion, the base. Again, we have the equation for the concentration inverse of the log, okay, 10 to the negative pOH. So you got to plug that into your calculator. This time, negative pOH. The pOH we found was 11.7. So it's going to be 11.7. So plug that into your calculator, please. Let's clear this. Do the inverse of the log so that we have this 10 to the x. And plug in negative, I forgot, what was it? Negative 11.7. 11.7. And your concentration will be 1.9952623 to the negative 12. All right. And going back to this problem, still using 2 sig figs here. Yeah, 2.3, 11.7, that's 3 sig figs. We're going to use the least amount of sig figs. Oh, that reminds me. Let me put in that other one just to be accurate. So 2 sig figs, that will make it stop right here. So round that up, it'll be 2.0 times 10 to the negative 12. 2.0 times 10 to the negative 12 is your concentration for the base. Okay. Now, that's how you do this problem. And I want you to try the last problem, the last set of problems on your own. Okay, following my example. Find a pOH using that equation, pH plus pOH equals 17, and use the inverse log to find the concentrations of the acid and the base. Now, if you're able to do all of this, you should be able to satisfy the objective. So make sure, are you able to predict the products in acid-base reactions? Do neutralization calculations using normality? Calculate pH, pOH, and their relative concentrations. If you can, then you have succeeded for this lesson. And I'll see you guys next time. Take care. Bye.